In this video, I'm going to show you some crucial tips to achieve perfect topology every time. This mesh was sent to me by a subscriber on Discord, and we will see that there are quite a few mistakes to fix. Let's get started. To begin with, I'm only going to keep the profile of the mesh. I'm going to isolate it by selecting one face, press Shift G and choose Coplanar. This will select all the flat faces on the same axis. Then I press Ctrl I to invert the selection and delete the faces. For practical reasons, I'm going to remove the mark sharp effect because the blue edges are visually distracting. Now that everything is ready, let's zoom in a bit and analyze what's wrong. The first thing we can notice is the poor edge flow and the huge difference in polygon size. Ideally, the outer polygons should all have the same thickness and loop all the way around the mesh when selected. Here, for example, they form a loop because they were unintentionally redirected. The second thing we can notice is that the topology is a bit messy in this area. We can see that there was an attempt to redirect the edges to reduce their number, and there are also non-straight edges. Around the half circle, the edges should follow a trajectory like this in order to maintain proper deformation when using a subdivision surface modifier. If we select these polygons, we can clearly see that the edge flow is wrong. The selection goes off to the left. Same thing on this side and on the next half circle. There is also an issue with the curvature of the half circles, but we will deal with that later. The model is symmetrical, so we can delete one half to work faster. First, I'm going to delete all the edges to start from scratch, and I will rebuild a cleaner topology. To do this, I select all the faces and press Ctrl X. This deletes everything while keeping the overall shape of the mesh. Now let's remove the unnecessary vertices to keep only a clean base. Let's keep these vertices at the bottom because they don't cause any problems and they are evenly spaced. We can connect these two vertices by pressing J, then these two as well. We can delete all the vertices between the edges. Here it's the same. We can delete these vertices and slightly reduce their number because there are many more on the left than on the right. We will come back to that later. You can download my beginner 3D modeling ebook called Mastering Topology and Hard Surface Modeling. It includes tips and tricks to work faster and more efficiently, the most common mistakes beginners make and how to fix them, and many other helpful insights. 13 years of experience gathered in one place. The link is in the description. We can start by connecting these vertices, since this is the simplest section. Now let's talk about the half circles. We can see that the distance between the vertices isn't consistent, and the curvature is no longer that of a proper half circle. This can cause serious shading issues later. Let's select the two top vertices, then press Shift S to open the pie menu and choose Cursor to Selected to place the 3D cursor at the center of that selection. This will allow us to create a new 8-sided circle perfectly positioned there. Previously, we had an 8-sided half circle, which means the full circle had 16 sides. We can cut that number in half since we're going to use the subdivision surface modifier later. We now have a new problem. On the left side, the geometry is above the vertex, and on the right side, it's below. To fix this, I select these edges, change the gizmo to bounding box center, and press SZ0 to align everything on the same axis. Next, I'm going to snap the vertices of the mesh onto the circle's vertices to recreate the correct curvature. To do that, we enable snapping and set it to vertex. Then in edit mode, we select the vertices and snap them onto the circle. And I delete the extra vertices. To move the circle precisely to the next hole, I reselect the two top vertices, I press Shift S and I choose Cursor to Selected, then I select the circle, Shift S, Selection to Cursor, and I repeat the same steps for all the holes. It's time to rebuild the topology, but we still have one last issue to fix. The number of edges at the top doesn't match the number at the bottom, and the curvature is also wrong. The vertices are not evenly spaced. To fix this, we select the edges, right-click Loop Tools, Space. Now we can connect the two middle vertices, then connect the others in this way, and delete the extra vertices. Let's reuse the space function to recreate uniform spacing. We do the same on the right, connect the edges and use snapping to create a straight edge. Let's delete the extra vertices and let's use the space function again. We can add 3 edge loops by pressing Ctrl R. Why 3? This is because that gives us polygons with the same thickness as the surrounding ones. We want a relatively uniform polygon density everywhere, and I'm not going to deal with the right side of the hole yet because the topology is a bit more complex. For the last half circle, I'm going to use the knife tool by pressing K, and if we press A, we can create straight cuts aligned with the axes. Let's create one cut on each side. Then subdivide the bottom edges to add vertices. We can finish connecting the half circle vertices. Then add 3 edge loops again and connect them like this. The right side is fixed, let's move on. I'm going to connect the 2 half circles together and add another vertical edge loop. Between these 2 vertical edges, I can't use Ctrl R because we have an n-gon. So instead, we select these edges, right-click, subdivide, and set the value to 2. Then we add 2 horizontal edge loops. And as before, we add 3 edge loops on the left. Next, we add 2 horizontal edge loops across the rest of the mesh and connect everything by adding a few edges. Let's connect the corners like this. Then add enough edges along the long left side to maintain uniform polygon density across the entire surface. As you can see in this area, the curvature is not perfect and the vertices are not evenly spaced. To fix this, I first add a vertex on the vertical edge and move it slightly upward. Then I select the curved edges, right-click, Loop Tools, Space. We can also use the relax function to smooth out the curve. Let's connect the vertices like this and even simplify the curve by deleting some vertices. There is no need to have too many. If this breaks the curvature, let's recreate it using the space and relax functions. We add our 2 center edges and connect the vertices. I can use the knife tool to create a support edge at the bottom and delete the remaining vertex on the left. It's useless. And I can connect the corner vertices like this, but we'll come back to that later. Now we are going to give thickness to the mesh so we can add a bevel. This bevel will act as a protection for the shape. As I showed at the beginning of this video, we want a continuous edge flow all around the shape with the same thickness everywhere. To do this, I select the sharp edges, deselect the edges of the half circles, Ctrl B to add the bevel, I set the shape value to 1, I press C to avoid overlapping edges, and I disable loop slide to get a uniform bevel shape. Watch what happens when I enable or disable it. The final step is to set the miter outer to arc. We can now remove the mesh thickness. To connect the corners, we have 3 methods. The first one is to use the knife tool and add cuts like this, always one edge after the bevel to avoid deformation. Then delete the central edge and use GG to slide the vertex along its edge. The second method is to add cuts like this. And the third method, which I'm going to use, is to use the knife tool and connect the vertices like this. Don't forget to delete these small edges at the top, and let's do this everywhere. For this section, it's more complicated. We can't do the same thing on the right because the shape is different, and the bevel support vertices are already used for the bottom edges. I can simply add edges and redirect the topology. Now let's get back to the most complicated part. As you can see, we only have 2 edges at the top and 12 at the bottom. So how do we connect all of this without adding a huge number of useless edges? I'm going to use localized topology. I'm only going to add edges on a specific area without subdividing the entire mesh. First, I'm going to connect these vertices differently on each side. Let's delete these non-straight edges. Then recreate them using the knife tool. At the bottom center, we have a small triangle. We can merge the 2 center vertices by pressing M, merge at center. I select these two edges, right-click, subdivide, and add two edges. I'm containing the geometry in this specific area instead of adding two edges across the entire mesh. Using the knife tool, I create cuts like this and then connect the vertices. We can repeat this exact process several times with the neighboring vertices. And as you can see, the topology is concentrated in a single area, and we didn't need to subdivide the entire mesh. Now let's see what happens when we add a subdivision surface modifier. We can see that because of the poles we created on the bevel edges, the faces deform unevenly around the mesh. This is bad because it will result in incorrect shading, and the light won't reflect properly in the render. To fix this, we can select the faces while excluding the bevel and press I to create an inset. This adds protective support loops before the bevel. However, we need to fix the corners using the knife tool like this. Let's do this on all the convex corners. And here at the bottom center, we can remove the triangle by adding a bevel to this edge. Our profile is now ready. We can extrude it to add thickness and insert support loops. I will make a dedicated video about localized topology because it's something that beginners often misunderstand. If you learned something in this video, please consider subscribing. It's free and you can always change your mind. Thanks for watching.